This is the order of a group element, powers of a group element. We use index notation. If G under composition is a group, then X is contained in G. So X squared equals X composed X, and X cubed equals X composed X composed X, and so on. We interpret X1 to be itself and X0 to be the identity. Likewise, X to the negative 2 equals X to the negative 1 composed X to the negative 1, and so on. Now, powers of an element of X contained in G under composition are defined. Let n be a positive integer, then x0 equals our identity. X to the n equals x composite x, and so on composite x, and we have n copies of x. Now x to the negative n, and we have n copies of x to the negative 1, and so on. So each power of x is an element of G, since G is closed under composition. Now here's an example: the non-trivial elements of S squared. We find S, C0, C1, C2, and so on, C5. Answer: C0 equals our identity, and C1 equals C, and C2 equals C, composed C equals B. Now C cubed equals C composed C composed C. Now C composed C is C squared composed C, and as above we have C squared is B, so B composed C is A. And we do it with the C to the 4 and C to the 5. C to the 4 gets our element, identity element back, so we're dealing in cycles of 4 here. So as you'll be able to see through our rotations above, that looks right. And C to the 5 gets us back to C. Now we have index laws as well. If m and n are positive integers, x to the m composed x to the n equals x m to the m plus n, and x to the m in parentheses to the n equals x mn. And x to the n to the minus 1 equals x to the minus n equals x to the minus 1 to the n. Now definitions: let x be contained in the G under composition if there is a positive integer n such that x to the n equals e, our identity, then the order of x is the smallest positive integer n such that x to the n equals e. We say x as a finite order. If there is no positive integer n such that x to the n equals e, then x has infinite order. An example: order of an element A in S triangle. And we have our symmetries there: rotation AB, reflections RST, and so on. So A squared equals A composed A equals B, and which A composed A equals B, and A cubed equals A squared, which is B composed A. So it's B composed A equals our identity element, because if we're doing another rotation we get back to where we started here. So this is our identity. So A is A in S triangle as order 3, and that's the order of an element of a group. Thanks for watching, and please do like and subscribe.